I'm Galen, and I'm the Local Motors lab supervisor. I also do a lot of the fab work for the R&D prototyping side of things. What we have here is the main part of the aerial cruiser frame. This is the first prototype that we're prototyping. You can see around it the aluminum jig that we're using to square up the two key components. This chassis is unfinished and the jig is also unfinished. So there would also be a third component back here. The rear axle would also be located, and that is so all three of these parts are perfectly in line, these two being parallel, this one being perpendicular. And there's 4 aluminum cones that actually center these pieces perfectly, and these pieces will all hold bearings, so these cones are the best way to actually locate that bearing race, where the bearing race would go, and square it up in relation to the jig. These gussets right here were cut out on the water jet, and they also served as an angle finder for me when I welded this together, so this is at the exact angle that it needs to be for the frame to be dimensional. And of course, with any jig, that's the idea behind it, is to make a repeatable product, and so your dimensions are retained and very accurate. And in this case, where you have these very small metal pieces with bearings locating something, if you have a very small error here when it's on your pedals, it actually ends up being a very big distance that it's off. So it's very important that this is accurate. So this jig is similar to other bike jigs in the sense that it locates the main piece, the bottom bracket and everything. Normally in a bike jig, the jig will also hold your main chassis tubes as well. Because this chassis is so unique, you know, it's designed to be kind of a flat track racer theme. So obviously the tube runs are not conventional, they're not straight tubes. So there was no way to locate these tubes in this jig. This jig's just for welding the main components in. The way I built this was actually laying it on a sheet that's scale printed. So it's a CAD printed drawing of these bends and everything. And these pieces were fabricated and laid over that sheet. And then they were tacked together and stitched. And then I took it basically off the sheet and put it into the jig with these main components, the head tube and the bottom bracket, and soon to be the axle tabs, dropout tabs, and then welded the rest of the way. And so these key pieces are still very dimensional. Eventually we will have a jig for locating all these pieces to keep them in plane. So we will have 2 jigs, weld jig for this, and then this aluminum jig here that you see here for locating the bottom bracket and the head tube. So other than the jig being aluminum, the frame is actually all chromoly, so this will be a quality higher end bike, and it is all TIG welded. Some of you may distinctively notice these smaller beads and the color lines and everything, so you can kind of tell that it is TIG welded. This is in fact the welder that I used to weld this all together. It's a small inverter style welder, which means it'll take AC from the wall, chop it up, invert it actually, and the DC current that comes out here, I can actually adjust the current. And in most DC welders, you set your amperage, and so you have a flat DC amperage. So this actually has pulse adjustments, so I can have a clipped square wave that actually pulses at a given hertz that I set, a given frequency, and I can set my high time and my low time. That gives me a very stable arc that is actually somewhat cold, so I can weld this real thin tubing and have very good heat control, but also have a good sized puddle and very good arc stability. So that's something that's a little different than, if you look over here, this bigger welder doesn't have any waveform shaping adjustability, and that welder worked great for welding this thicker stuff, but there's no adjustments to do a very stable arc when you weld something thin that needs very petite control of the heat setting. If you want to know more about this project, the development, the processes that we used and went through, and the design challenge, go to Local Motors Forge, look under projects, and this is the aerial cruiser development prototyping project.